So the software part of it, let's look at where the various generations of the web fit in to the complexity theory. Web 1.0 is mostly in the best practice area. You know, we've got the best practice and we're going to tell you what it is. Because you get into reference documents that are used by experts, it kind of bleeds over into the complicated domain. Web 2.0, you get, certainly you're facilitating through the communication, the dialogue of experts. But again, Twitter and the social web are great levelers. So it kind of elevates a lot of people to expert status that would never have been considered as such. But there are some complex effects that happen when you do that. For instance, you get bogus information on the web, right? You can get good information or bogus information. The Web 3.0 is kind of interesting. It contracts a little bit more towards back towards the complicated domain, the way that it's typically applied, because this notion that we'll have our experts develop our ontologies and then we'll apply those and then everyone can just use the ontologies to interpret all the data that's available on the web, again, it puts us back more into the control of the experts that are already out there. Where things are actually going, however, is much more interesting. This is from a company in the UK that assists other clients, companies, with thinking graphically. It's a very messy kind of a process. And so they assist them. They'll, for instance, supply a graphic artist who's also trained in the cognitive techniques to facilitate the dialogue, capture the thinking in the form of pictures, and then that activates the great strengths in the human mind in pattern matching. And so, for instance, we have quotes like this one from a manager in a technology company about how they would take minutes in the meetings in the form of pictures rather than words, and that led to a different kind of a conversation and different kinds of thoughts, because they were tapping into the strengths of the human mind, the things that you don't find in tool support and, you know, in web apps and so forth. And she made the comment here, just having the picture made her rethink a whole problem in a way that she would not have otherwise. So if we can't really get to Mr. Smith of the Matrix, where are we going with the Web 3.0? And I think this gentleman has a lot to say about that. It's Eric Schmidt, the CEO of Google, and he answers a question about the Web 3.0.
And my prediction would be that Web 3.0 will ultimately be seen as applications that are pieced together. And there are a number of characteristics. The applications are relatively small. The data is in the cloud. The applications can run on any device, PC or mobile phone. That the applications are very fast and they're very customizable. And furthermore, the applications are distributed by virus, essentially virally, literally by social networks, by email. You won't go to the store and purchase them. You'll say, I'll send to you, Ken, you know, here's this interesting new way of doing one thing or another.
Okay, so given that, where does Ada fit in the Web 3.0? And this I'll have to operate from my computer. So the traits that Eric Schmidt brought up, I'd like to drill down in those a little bit. So he talked about fast execution, and we know that Ada can produce efficient code. So I'd rather get into the aspect of speed that has to do with writing things quickly. And there's several aspects to that. One is that, you know, there's this distinction between your speed in coding and your life cycle speed. So if you think of it just in terms of coding, there are certainly things that you can write in that code much faster. However, if you think in terms of if you can produce high-quality code that's right the first time, and you can avoid all of the rework loops and so forth, or at least most of them, that, that can greatly accelerate the overall development of software. And there's this idea that comes from lean, from the world of lean principles, called poka-yoke. And there's two levels of poka-yoke, which is sometimes translated mistake proofing. The first level is that you preclude errors from ever being introduced in the first place. That's actually an approach I've mostly used professionally myself. It's very effective, and then there's a number of characteristics in the Ada language that contribute to that. The second level of poka-yoke is that if you do allow the introduction of errors, that you have a way to catch them immediately and remove them so that you don't get into this, this iterative, correct, improve kind of a situation that you do in normal development. And again, Ada has various capabilities that address that. I'm not going to read all the capabilities off because you can do that yourself. Then he spoke about what I would sort of sum up as constructability. And there are certainly Ada traits that contribute to construction of code. Now, this is a very interesting thing because it kind of brings us full circle back to Station X and Bletchley Park. There was a competition in 2007 for people to write code that would break the German ciphers faster than Colossus did back at the beginning of World War II. And whoever could write the fastest code breaker would win the competition. So this individual, Joachim Schultz, did not know how to program in Ada, but he decided to use Ada because, well, for reasons we'll get into in a minute. But what he discovered as he used it was that he was able to construct code that very much corresponded to the different pieces of the German encoding machine, which had, wheels and gears and all sorts of things, and put it together very much like the machine. It's very understandable. The language is proven to be quickly, easy to learn, quick to learn, and again, Schultz made the comment that that was the main reason, actually, that he picked it in the first place, was it was very quick to learn. And the language has a logical design. It was thought out, from the very beginning. Okay, as far as piecing things together, 3 times shows up in the WG9 memo to the ARG of 2002. The emphasis on interfacing shows up 3 times. So there are various things that apply in Ada to piecing things together. Certainly interoperability. And I thought this was just a great quote from Ada Core on that in the Java approach, it inserts a middleware layer, which is not as elegant and presumably slows things down. Then we have strongly typed separate compilation, all of the supports for OO that everyone here knows about. Tools for integration have been coming along very nicely, and of course, here's a couple that were actually part of the conference agenda this week. Ability to run on any device. There's, again, a number of provisions in Ada, characteristics of Ada that support that. And then for customizability, I think other words that can kind of serve as synonyms, emergence and modifiability. Again, there's a number of things that are very strong in Ada in support of these. In addition to the traits that Schmidt brought out, though, I think there's a couple more that are very important because the web's being used for more and more critical applications. Banking is an obvious one. But there's just many things that we've come to depend on the web for. Our ability to communicate with our loved ones in crisis situations and so forth. So things are just going to become more and more critical as time goes on. And probably this audience is probably the most educated in the world on what are the things in Ada that support that. So I just list some of these for completeness sake. But I think it's very, very interesting the work that the OpenDO.org, the organization, OpenDO organization, has been doing in the area of combining emergence and high integrity. And you can go to their website and see a number of presentations that discuss that, where people have done that in aerospace and in various other domain applications. And then the notion of autonomous agents, which, if you're not talking about Mr. Smith, at the moment, what you're talking about more is things like multi-threading and multi-core support. And Dr. Dewar had a great article in EE Times in 2008 where he made the comment that we're well aware of, that Ada it's been at the heart of Ada for a long time, the support for multi-threading. We have a comment here about the safety of the multitasking mechanism in Ada relative to Java. And again, more comments about that. All right.